To bundle multiple physical link into single
Single logical channel.
logical link. Right. Now, as I told you, we have three methods for ether channel. Right. First one is static method. Static. Second one is dynamic. We can use protocol like PAGP, and third protocol is LACP. Okay. So first of all, we will see the static configuration, guys. How we are going to, bundle multiple physical link into single logical link with the help of static method, manual configuration. Okay. So see here, I have same topology in EVNG. If I will access these switches on this switch, so a spanning tree. Both port of this switch 0/0 and 0/1 are in forwarding state, and DP, because this switch is root bridge. But on switch number 2, one link is block. So a spanning tree. 0/1 is alternate port, right? Status is blocking. That means if PC1 want to communicate with PC2, switch 1 will forward traffic from E0/0 only. From E0/0 only, right? Lower link is in utilize. Okay. So if you want to use both link, what you need to do here, either you can disable a spanning tree protocol, right? But again, if you will disable a spanning tree protocol, what will happen? Loop will form there, right? So another method is ether channel. With the help of ether channel, how we can bundle these two port. See on switch number one, what I will do, interface range E0/0 and E0/1. Before configuring ether channel, you should shut down the interfaces. And guys, in last class, as I told you, there is some requirement of ether channel. Like requirement of ether channel is like a speed should be same. A speed should be same of both link. A speed of both links should be same. Then as I told you, duplex should be same. Then all ports should be access port or trunk port. Should be access or trunk. Then trunk encapsulation protocol should be getting noise.
VLAN and native VLAN should be same, right?
Yes. Trunking encapsulation protocol should be same. Then allowed VLAN on the list, on the trunk link. Allowed VLAN should be same. Right? Then native VLAN should be same. should be same, right? So these are requirement of ether channel. Okay, so by default SP, duplex, encapsulation protocol, trunking, allowed VLAN and native VLAN are same on both interface, on 0/0 and 0/1. So we can form ether channel here, right? But before configuring ether channel you should shut down the port. This is just a recommendation, right? You can avoid it also, but sometime you will face some issue if you will not shut down the port and you will configure ether channel. So that's why it's a recommendation that whenever we are configuring ether channel, first we should shut down the port, and then after ether channel configuration you should run no shut command. Okay, so let me shut down the port and then we can say channel group, right? This is command channel group. Then we can use a group number from this range 1 to 255, 1 to 255. So let me use group number 1 here, group number 1, and then mode, right? So in a static method mode will be on, and if you will put question mark here you can see how many modes we have, right? On is there. On mode means we are configuring ether channel manually both side, we are not using any protocol. And active and passive, these two modes are for LACP protocol, and desirable and auto, these two modes are for PAGP protocol. So if I will set mode auto over here, automatically PAGP protocol will enable. If I will set mode active over here, automatically LACP protocol will enable over here, right? If I will put mode on over here, right? So this is static method. Then both side you have to configure on mode. Fine. And guys, in PAGP we have two modes. First one is auto and second one is desirable. So desirable mode is exactly like dynamic desirable in DTP, right? It will always initiate the ether channel, it will always initiate the bundling, and auto will always wait, right? Let's say on switch number 1 if I will configure desirable, and on switch number 2 if I will configure auto, right? It can form ether channel, right? But if both side mode is auto, then ether channel will not come up, because auto is exactly like dynamic auto in DTP protocol. It will always wait for negotiation, it will always wait for initiation, right? So if neighboring switch will initiate the ether channel, then auto mode can change there, they can means auto mode can form ether channel, right? But it cannot initiate. In the same way in LACP we have two mode. First one is active and second one is passive. Again active is same like desirable, right? It can initiate the negotiation, and passive can only wait, right? Passive cannot initiate the negotiation. So in PAGP protocol if I will configure what auto mode, one side auto and another side also auto, will ether channel come up? No, no, right? One side mode is desirable and another side mode is auto, will ether channel come up? Yes, right? Both side mode is desirable and desirable, will ether channel come up? Yes, right? Fine. In the same way in LACP active and active can form ether channel. Yes, active and passive can form ether channel. Yes, passive and passive can form ether channel. No. Done. So here in my scenario I am going to use mode on now, right? So you can see creating a port channel interface, and name of port channel interface is port channel 1, right? Now here if I will run command, so interface status, let's say, So we have one port channel as well. You can see port channel 1. Fine. So this port is down now, right? So this port is, you can see, unassigned, right, for VLAN, and this port is not connected with any device, so not connect. So interface port channel 1, we can say, right, to check detailed information about this port. So MTU, you can see 1500 byte. This is bandwidth of this physical this logical interface, right? Status is down, line protocol is also down, right? And second command, show ether channel summary. So ether channel summary. So with the help of this command also, we can say we have one group, group number 1, name of port channel is PO1, and how many interfaces are there in this port channel? 2, 0/0 and 0/1, 0/0 and 0/1. Now I can run no set command on these interfaces. Interface range is 0/0 and E0/1. Say no set here, right? Now so IP interface brief, I can run this command also. You can see this port channel is up now. Line protocol is also up. Status is also up. Earlier this port channel was down. Here you can see SD. D is indicating what? Down. S is indicating what? It is a layer 2 ether channel, right? So we can form layer 2 ether channel as well and layer 3 ether channel as well, right? Right now we are talking about layer 2 ether channel, right? So earlier this port channel was down, but now if you will run command show ether channel summary, so you can see now your port channel is up, U indicating up, right? In the same way on switch number 2, and here if you will run show spanning tree protocol now, so you can see now spanning tree protocol is running on which interface? This interface, right? This is previous entry, right? On real devices you will not see these two, interfaces. Now this is 0/2. Okay, this is 0/2 and 0/3. This is not link between switches. Okay, so let me down E0 slash interface range E0/2.
Why is cost 56 for the port channel?
Sorry.
Evo 1. Cost is 56, right?
Yes, cost
Here.
of STP.
So cost is less for port channel.
This is, cost of STP. I don't know how STP is calculating cost. Like it have calculate cost on Ethernet cable, right, 100, on fast Ethernet cable 19. In the same way on port channel it have calculate cost 56.
Then the priority also 128.65, right? What
65.
is that 65? Uh, for 0/3, it puts 3 like that. You you taught like that, right? Before how it assigns that port number.
Port priority. Port priority for physical interface is 128 dot, like let's say for 0/1 is 128.1, right?
Yes.
Right. On port channel 1 it have, set this port priority. I will check it later, don't worry, right? What is
Okay.
this? Okay. Now I am going to down these two interface, right? So now you can see so spanning tree. So spanning tree protocol is working on this interface now, right? Not working on these physical interfaces. Fine. In the same way on switch number 2 also, I'm going to bundle these two interface range E0/0 and E0/1, channel group number 1, or this number is locally significant. We can use different number here also, right? Group number, I can use 10 also, and then say mode, what, on. So ether channel summary. So this port is also up, and these are two interfaces in this port channel. right? And here also show a spanning tree protocol. So a spanning tree protocol is working on port channel now. A spanning tree protocol is not working on these interfaces 0/0 and 0/1. Interface range is 0/2 is 0/3 is 0/1/023. I'm going to set these interfaces, set down. So a spanning tree. Now a spanning tree is working on port channel only, right? So now we have only one logical link between switch 1 and switch 2, right? And a spanning tree protocol is working on that port channel, that virtual link. So again on switch number 2 I'm going to up only this interface E0/1 interface 0/1 say no set, and on switch number 1 LAN interfaces interface E0/2 say no set, right? So ether channel summary, right? And so ether channel we can use this command also. This is also one verification command. Like we can check detailed information, we can check port, we can check protocol. So protocol mode is what? On. That means it is a static method, right? In dynamic method here you will see mode can be on, mode can be active, mode can be passive, mode can be desirable, or mode can be auto. Here we are not using any protocol here right now. So this is a static ether channel configuration on a particular interface. Also we can check show ether channel, and then we can say which command, let's say detail. So it will show you detailed information on each port, like on E0/0 what is mode. So this, let's say you need to troubleshoot, my ether channel is not coming up, so you will troubleshoot, like on both ports we are running same mode or not, right? So on E0/0 see, you can see mode is on, right? You can check here also on 0/1 also mode is what? On. Then you can check group number should be same, right, on both interface. So you can see group number is also same. But like in this scenario, let's say we have two more link between switch 1 and switch 2. We have two more link between switch 1 and switch 2, and I have bundled these two interfaces in different port channel. This is in P2 and these two ports are bundled in P1, right? So again a spanning tree protocol will work on these two logical interface, and a spanning tree protocol will block one logical interface, maybe this interface or upper interface. So if you have multiple port channel between switches, a spanning tree protocol will allow only one port channel. Otherwise again loop will form. Why? Because in last class what I told you, that whenever switch will receive broadcast message, right, it will check I am receiving broadcast frame on the interface which is member of which port channel. So I will not forward this broadcast message from any interface which are member of same port channel, but switch 2 can forward it from another port channel interface. So again loop will form here, right? So if we have multiple port channel between switches, again a spanning tree protocol will work same like on physical interface. It will block one logical link.
Maximum how much interfaces we can bundle?
In a static you can bundle up to 8 link. In PHP also you can bundle up to 8 link. In LSCP you can bundle up to 16 link, right? But again only 8 links will be in active state and 8 link will be in standby state. So when any active link will goes down, then a standby link will come in active state. So at the same time max to max 8 link can be in forwarding state in all method, in on method also, in PHP also, and in LSCP also.
What is the difference between static and LACP?
LSCP is dynamic, na? It is protocol. With the help of protocol, what is difference between a static route and dynamic route? In the static route, manually we are configuring route. Manually we are injecting route in the routing table of router. In dynamic routing, what we are doing, we are running a process on routers. According to that process, routers are exchanging routes. In the same way, in a static, manually you have to configure both side. Dynamic, sorry, mode is on. And in LSCP, you will run protocol. According to that protocol, definitely here also switches is going to exchange some message, right? When we will run
Where we
protocol, yes,
where we configure static and where we configure LACP.
you can configure a static here also, you can configure here protocol also.
No, I'm asking for the production. In the production, how
Generally
where
we are
they
using LSCP protocol in real time. We are not using a static method and we are not using PAGP as well, like because PAGP is Cisco proprietary. In a static, in static we don't have, much option for load balancing in LSCP. And another advantage of LSCP is in a static method you can bundle up to 8 link. In LSCP you can bundle up to 16 link.
but you told 8 link will be
Yes,
active
but you
and
can bundle na 16. So 8 will be, see here, if I have bundled 2 link here, right? If one link will goes down, right? Now how many link are there in active state? Only one. But in the same way, if you will configure, let's say here we have one more link, right? I have bundled these 3 link in static in EtherChannel with the help of a static method. So if this link will goes down, there are 2 link, right? If we have more than 8 link between switch 1 and switch 2, more than 8 link means maybe we have 9 link. So if out of 9 link, 1 link, sorry, 8 link will be in active state, and on one link you are not running ether channel, right? So if any port from 8 links will goes down, right, automatically, remaining one port which is in a standby will not come in active state. That will be still in a standby state in a static method. But in LSCP, if out of that 8 port, one port will goes down, automatically remaining port will come in active state. Okay, so this is guys a static method configuration. We have some verification command, so ether channel, and then we can use these all command, like we can use port channel number, we can say auto over here, we can use load balance command over here to check which load balancing algorithm is running. So which load balancing algorithm is running by default? Source and destination IP address, means on the basis of source and destination IP address, this switch will perform load balancing.
How it will do? Can you please explain this
L-
source and destination?
load balancing.
Yes, yes.
Okay, wait, I will. Protocol, then we have summary command. Generally we are using this command, right, for troubleshooting ether channel summary. Okay, now first of all let me configure any protocol here. Interface range E0/0 and E0/1. I'm going to remove this command, no channel group 1 mode on, right? I will run this command on switch number 2 also. Interface range E0/0 and E0/1. Do so ether channel summary, right? Now, how to configure protocol? See, to configure protocol also, just you need to change mode. Interface range is 0/0 and is 0/1. Here we can say channel, group, mode. If I will say desirable, channel group number one, mode, let's say desirable. That means we are running which protocol here? PAGP. And so ether channel summary. Here we are able to see protocol. No, protocol is PAGP. And which mode I have configured here. So for that, what command I can run? So ether channel detail. It will show me port on all interfaces. Right? Protocol is PAGP. On switch number 2, I can configure either desirable or auto. Interface range E0/0 and E0/1. Channel group mode auto. Right? So it will take some time. Soon it will come in. This port channel will come up. Fine. Okay, in LACP, if I can bundle 16 link. Let's say I have two switch 1 here and switch 2. Most of the time, guys, interview will also ask you question from LACP protocol only, right? Like how switches is going to, decide which port will be in active state, which port will be in standby state. So let's say here we have 16 link. 1, 2, 3, 4. Because in static or in LACP, we can bundle up to 8 link. All will be in active state, in forwarding state. In LACP only, we can bundle 16 link. So, and 8 link will be in forwarding state. So try to understand which 8 link will be in forwarding state. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, so let's say this is 0/1 interface. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So port, see, in LACP actually there are port role. Port will have LACP port ID. Like in a span tree we have what? Port priority for each port. In the same way in LACP we have LACP port ID. Right? Each port will have one LACP port ID, and LACP port ID is nothing but combination of again two things: LACP port ID. It is combination of two things. First thing is priority, and second one is interface ID. Interface ID. And by default priority is 32768. 32768. Right? So what will be LACP port ID of this interface? 32768 plus 1, right? So it will represent like this: dot 1, dot 2, dot 3. And first 8 port who will have lower LACP port ID, those port will be in active state, and rest 8 ports link will be in standby state. Getting my point? So these 8 ports will be in active state, and these 8 ports will be in standby state. Now again we have one problem. Let's say here on switch number 2, this is my link number 15. This is 15, this is 14, 13, 12, 11.
16 or 15?
Sorry, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now on switch number 1, these ports should become active, and on port switch number 2, these ports should become active because these ports have lower LACP port ID. Yes or no?
Yes.
So now here let's say we have one user, and here also we have one user. Can these users communicate with each other? Can these users communicate with each other? No, because there is not a single port in forwarding state. So first of all, when you will enable LACP protocol, first of all, once you will enable LACP protocol, one switch will become main switch. One switch will become main switch. Switch who is going to decide which port will be in forwarding state and which port will be in blocking state, right? Like in a span tree protocol, we have root bridge. Like that in LACP, one switch is going to become master switch. Now again question is, which switch will become master switch? Which switch will become master switch or main switch, right? So for that guys, in LACP we have a term called system ID. System ID. Switch who will have lower system ID, that switch will become master switch. And system ID is again combination of two things: priority plus base MAC address. Base MAC address. Okay, again priority is by default 32768. So let's say switch 1 MAC address is 0A and switch 2 MAC address is 0B. So system ID of switch 1 is 32768 plus 0A, and system ID of switch 2 is 32768 plus 0B. Now which switch have lower system ID? Switch 1. So switch 1 is my main switch, or you can say master switch, right? Now switch 1 will decide which port will be in forwarding state and which port will be in active state and which port will be in standby state. So according to switch 1, these 8 ports should be what? In active state. So according to that, switch 2 is also going to put these all interfaces in active state and these 8 interfaces in standby state. Is it clear?
Can we
So
increase the priority? Lower priority will be preferred, right?
right.
So can we decrease the priority
Yes, yes, of course.
and
Like in
make
a spanning tree, we can increase or decrease priority. Here also you can increase or decrease priority. Let's say you want switch 2 should be my main switch. So here you can configure priority 0.
okay.
Fine. Now, uh, Vasavaraj asked how load balancing is going to work, right? So see, if let's say in this scenario, switch 1 is connected with one router and this router is connected with ISP. Just I'm creating scenario, okay? Because of that I am connecting one router here and one ISP over here. R1. Guys, on real devices, you will see by default load balancing algorithm is source MAC address. Means switches will perform load balancing on the basis of MAC address, source MAC address, only on the basis of source MAC address on real devices. If I will access my switch in rack, just give me 1 minute. Yes, I have turned on the rack. Just wait for some time. On real devices, you will see by default load balancing algorithm is source MAC address. Means which will perform load balancing on the basis of source MAC address. So in this scenario, 8 links are in active state. These 8 links are in active state. So let's say here I have one user. Here I have one user on switch number 2. Right? This user MAC address is just suppose A. Right? And this interface MAC address is let's say C, default gateway. This will be default gateway for all the users. So whenever this user will ping let's say 8.8.8, source MAC will be what? A, and destination MAC will be what? C. Destination MAC will be C. When let's say here we have one more user. This PC MAC address is B. Right? So when computer A want to communicate with internet or outside user, source MAC will be A, destination MAC will be C. On the basis of source MAC address, switch 2 will perform load balancing, right? Let's say switch 2 have use this link to forward traffic. For computer B, it will again perform load balancing on the basis of source MAC. It will check source MAC is B. Let's say it have used this link to forward traffic or computer B. But for reply, when reply will come up right from ISP, every time source MAC will be C and destination MAC will be A, or C, destination MAC will be B. For all user, let's say here we have thousands of user or 100 number of user. For all 100 number of user, destination source MAC will be always what? C in the reply packet. So can switch 1 perform load balancing? No. Switch 1 will use only single link, because by default if it is performing load balancing on the basis of source MAC, so every time source MAC will be C in the reply packet. Definitely switches will perform load balancing for the traffic which users are generating, right? The traffic which is moving from user towards ISP, but for the reply packet it will use only single link. Yes or no? So we need to change load balancing algorithm in this scenario. So we have multiple types of load balancing algorithm, right? In EvenG, we are not able to see multiple load balancing algorithm, right? Here if I will run this command, interface range E0/0 and E0/1, shape channel group number 1, and then mode, let's say auto. Here, not here, you will run this command in I think global config mode. Port channel then load balance and put question mark. You can see how many load balancing algorithm we have. Destination, on the basis of destination IP address also we can perform load balancing. On the basis of destination MAC address also we can perform load balancing. On the basis of source and destination IP also we can perform load balancing. On the basis of source and destination MAC also we can perform load balancing. On the basis of source IP also we can perform load balancing, and on the basis of source MAC also we can perform load balancing. And this is default. This is default. By default, switch MAC switch running source MAC address algorithm for load balancing, right? And guys, if we have, let's say, 8 link, so to represent 8 link in binary, if you need to represent 8 link in binary, right, how many bits is required? How many bits is required to represent 8 link? 3 bits. Can I represent 8 link with the help of 2 bits?
No, no.
No. 2 bits can be 0 1 0 0 1 0, or it can be 1 1. So we can represent only 4 link with the help of 2 bits. So I need how many bits? 3 bits. So if load balancing algorithm is source MAC address, when switch 2 will receive frame, it will convert source MAC address into binary, and it is going to use last 3 bits. So if I will convert A into binary, what will be binary of A? 1010. So it is going to use last 3 bits. Now it will convert these 3 bits into decimal value. So what will be the decimal value? 2. That means switch is going to use link number 3. Switch is going to use link number 3. It will forward traffic from this link. In the same way, for this computer, load balancing algorithm is source MAC. It will convert source MAC address into binary. What will be binary of B? 1011. It will use last 3 bits. It will convert it into decimal. It will get value 3. So it will use link number what? 4. It will use link number 4. This is how it is going to perform load balancing. EtherChannel is going to perform load balancing. Clear? If we have only 2 link, let's say in this scenario, so to represent 2 link, how many bits is required? Only 1 bits is required. Yes,
0 or 1.
0 or 1. So if we have only 2 link in the port channel, and let's say PC1 MAC address is A, right? When PC will forward the frame to switch will convert A MAC address into binary. So again, binary of A is 1010. It will use last bit. What is decimal value of 0? 0. It will use link number what? 1. 0 plus 1. It will add 1. Right? So let's say LACP port ID of this interface is 363 priority plus interface ID. Let's say 1, and LACP port ID of this interface is 2. Right? So it will use this link. For another computer whose MAC address is B, again it will convert it into binary 1 1. It will use last bit. Decimal value of this binary is 1. So it will use link number what? 2. It will forward traffic from upper link. Right? So last bit's value can be what? Either 0 or can be either 1. So if we have only 2 link, so LACP will perform load balancing on 2 link. If last bit is 0, it will use link number what? 1. If last bit is 1, it will use link number what? 2. Clear? This is how it will perform load balancing. Clear, Vasavaraj?
Yes.
Okay. And have you understood what is problem with source MAC address?
Yeah, if suppose many users are there, means that time how it will take?
Yes. Let's say we have 100 number of users. Same thing will happen for all users. It will convert source MAC address into binary, right? If there are 8 link, it is going to use last 3 bits. Then it will convert that last 3 bits into decimal value, and it will add 1.
if that simultaneously that 100 users are using, means that time
That time also,
congestion will happen, or how it is?
why congestion will happen? Let's say in this scenario, we have multiple computers. Here we have one computer, here we have one computer. MAC address A, MAC address B, MAC address C, right? When this computer will generate traffic, it will use which link? Link number 1. When this PC will generate traffic, it will use link number 2. When this PC will generate traffic, again it will use link number what? 1. Because you can convert it into binary, use last bits, and then convert that last bit into decimal and add 1. And on real device, let me check I am able to access real device or not. Secure CRT. Yes. Which algorithm is running by default? Source MAC.
Source MAC address.
Yes.
Yes.
If you will change load balancing algorithm, yes.
If a router is connected to the switch and it selects one link, right? If it is a 1 gig link, if router is sending a 2 gig of traffic, how that how it how it the traffic will go in the
It will
same link.
drop one gig traffic. It will drop 1 gig traffic. It will forward only 1 gig traffic. If let's say we have two devices here, router 1 and router 2. Let's say here we have 10 Mbps link, and if R1 will receive a traffic whose size is 20 Mbps, in this scenario what router 1 will do? It will forward 10 Mbps traffic and it will drop 10 Mbps traffic.
But port channel is there, right? There are 8 links there. One link is selected and 2 gig of traffic is coming, means what happens?
It will drop 1 giga traffic. 1 gig traffic.
Then what is the purpose of port channel?
What is the purpose of port channel?
To
I
increase
didn't
the
get your
band.
question.
But sir, the router also can keep those 10 meg in the buffer memory. That's also another possibility
No, no.
in
EtherChannel
the
purpose is
interface buffer
bundling
memory.
multiple link together. But again, this is not like single link, right? Again, switch is going to forward traffic from physical link, right? So actually, we are bundling multiple link into single logical link so that we can achieve more bandwidth, but not on a single link. Again, we have two switch 1 and switch 2. Right,
I think
what I told you in last class, if we have two link here and this router is connected with ISP and my outside user are accessing my server over here, right? So sometime span tree protocol is not allowing both links, so this link is in blocking state. So because of that we are facing congestion over here, right? So I need to increase bandwidth over here so we can bundle these two link, right? But again we have two physical link here. So for one user, maybe traffic will go from this link, and for another user traffic will go from this link. So we are achieving load balancing on the basis of user traffic, right? We are not increasing bandwidth of a single link with the help of EtherChannel.
I think for that scenario, we need to configure the destination MAC address, right? Then it will utilize that all links. Like if suppose we have that 8 links.
Brother, this is if we are combining two link together through EtherChannel, let's say this is 100 Mbps link, this is 100 Mbps link, right? Now you have total bandwidth 200 Mbps, right? But this 2 Mbps is distributed on two link. This is not a single link. It can still forward traffic up to 100 Mbps. It can still forward traffic up to 100 MB,
But
not more than that.
I think it will utilize that both links, right? 100 and
Right,
100.
for one user maybe it will use this link, for another user maybe it will use this link, right? So this type of load balancing we are achieving here.
Okay, this thing we will achieve by using.
If you are thinking like here we have bundled these two link and we have now 2 mbps bandwidth, so if switch 1 will receive a traffic whose size is 150 MB, right, again switch cannot forward it, so it will draw 50 MB traffic. Okay,
If you use some other load balancing,
But the Swiss
then
will
also,
store the 50 MB in the outgoing interface buffer memory before dropping it
yeah, definitely if it will put it in buffer
normally.
memory, that is also like it is not processing na at the same time.
Yep.
Storing in buffer memory or it is discarding, right, both are like same. Means it is not able to, means switch 1 is not able to forward 100 MB of data from switch 1 to switch 2 at a time, at the same time. So Dana,
Yes,
have you
yes, yes,
understood
that's
what is
true.
the purpose of ether channel now?
yes, I think if we change, you have lot of load balancing method, right?
Right,
All method you use only one link or multiple links.
only one link, how it can use multiple link? How it can use multiple link? Switch have to forward traffic from the physical link only.
Physical link only, 8 links are there, right? 8 links
Right,
are bundled together.
yes.
This load balancing method uses only one link. I don't know. Other
Another load balancing algorithm will also use only one link.
all the load balancing method use only one link.
Yes, it is not possible like if server is generating 500 mbps traffic, so it will forward 100 from here and 100 from here. This is not going to like this. In another load balancing algorithm, let's say if I have set load balancing algorithm source and destination, then what switch will do? Switch to switch 1, we have, let's say, only two link. Okay, here I have one user whose MAC address is A. Here I have one user whose MAC address is, let's say, B. So if this user will generate traffic, source MAC will be A, destination MAC will be B. Here algorithm, load balancing algorithm which is running is source and destination. Now this time this switch will convert source MAC address also and destination MAC address also into binary. So binary of A is 1010, binary of B is 1011. Now it will use last bit, so it will perform here AND operation. It will perform here AND operation, and after AND operation 0 1 will be what? 0. So it is going to use link number 1. Same thing will happen in case of source IP. Source IP, right? It will convert source IP address into binary. It will use last bit. Same thing will happen in source IP and destination IP, right? It will convert both source IP and destination IP into binary. Let's say this machine IP address is 10.1, this machine IP address is 10.2. It will convert 1 into binary. So binary of 1 is 1, binary of 2 is, right? So it will perform AND operation over here. It will again going to use which link? Link number 1, like this. So in all load balancing algorithm, right, switches is going to forward traffic from the physical link only, right? If we have 8 links, switches will use last 3 bits. If we have 4 links, switches will use last 2 bits. If we have only 2 bits, switches will use 1 link, sorry, 1 bit.
To select which to select which link among the
Yes, we,
code channel links.
correct. And let's say if we have 8 link between switch 1 and switch 2,
So I have one question.
yes,
In our company, we have two links. One link is a wireless link. It was like this before, but we
Okay.
currently facing packet loss. So we put
Okay.
another copper cable. So that means it's like in the diagram here, we have two links. But what we want the cable to be the primary active and the wireless to be the standby port, both in each channel. But that was not possible for us up to now.
No, you
We're
cannot
using
bundle,
LSCP
wireless link
with
and
two cable,
physically.
two links.
See, to bundle Ether channel, you
Yes,
have
yeah,
some
the port.
requirements. Here you have,
Okay.
Ethernet standard should be also match. Ethernet standard should be also match to form Ether channel, right? So on wireless adapter, your Ether channel standard is different. On Ethernet link or on fast Ethernet link, your Ethernet standard is different. So you can't bundle.
No, so the two interfaces are physical Ethernet interfaces because the other one we took from antenna. The cable is Ethernet cable connected to antenna, so we can consider it as
One
a
should
same
be
thing,
inactive and
internet
one should
internet.
be in standby. This is your requirement, right?
Like this, yeah, yes, like in this picture, in this
Then
diagram
why you
in
are bundling,
GNS3.
brother? A spanning, leave it for a spanning tree. A spanning tree protocol will put one interface in active state and one interface in standby state. When active will goes down, standby will come up.
Yeah, but we want the wireless to be the
If you want to
secondary.
utilize both, then
Okay, I
only
just
you should
want.
bundle it.
Okay,
So
okay.
if we have 8 link between switch 1 and switch 2, then load balancing algorithm will be like this: 1 ratio, 1 ratio, 1 ratio, 1 ratio, 1 ratio, 1 ratio, 1, 2, 3, 4, 5, 6, 7, 8. If one link will goes down, now we have how many link between switch 1 and switch 2? 7 only. So if we have only 7 link, then load balancing algorithm will be like this: 2 ratio 1 ratio 1 ratio 1, 5, 6, 7. If we have only 6 link, then my load balancing algorithm will, ratio will be like this: 2 ratio 2 ratio 1 ratio 1, 2, 2, 4, 5, 6, like this, right? Means it will forward 2 packet from link number 1, it will forward one packet from link number 2, one packet from link 3, 4, 5, 6, 7. 1 minute, guys. Yes. So if we have 4 links, which will check last 2 bits information.
I don't understand this ratio.
Okay, here I have 2 link between switch 1 and switch 2. So switch will forward one packet from this link and then second packet from this link. Let's say same user is generating, this PC MAC address is A, and this switch is connected with router, and this router is connected with ISP. Here we have 8.8.8.8. So if this PC will generate first packet, it will forward that packet from this link, right? If this PC is generating continuously packet after packet, packet after packet, so it will perform load balancing in this ratio. 1 ratio 1 means one packet from this link and one packet from this link. And to change load balancing algorithm, simply you need to run this command: channel port channel, then load balance, and after that algorithm. So on real devices, you can see we have destination IP address algorithm, destination MAC address algorithm, source and destination IP address algorithm, source and destination MAC address algorithm, source IP and source MAC. So by default, The algorithm which is running is source MAC, right? But in source MAC, as I told you here, what is problem? For return traffic, switch 1 will not perform load balancing, right? So either here we can use what? Source and destination MAC address. So again, if we will use source and destination MAC address, so every time source MAC address will be C, right, in the reply packet. So which type of algorithm we should use? Here I can use source IP and destination IP. Here I can use source IP and destination IP, so that both switches will perform load balancing on the basis of source IP and destination IP, right? So source IP will be 10.1, destination IP will be 8.8.8. It will convert both into binary, then it will use last 3 bits. Now guys, I have, let's say, one scenario here, switch 1 and switch 2. These are multi-layer switch. These are multi-layer switches. Here I have one computer. Okay, let's say one computer only. One computer is here, one computer is here. This PC, this is like real-time scenario. Say this is PC1, PC2. Okay, switch 1, switch 2, and this user is in VLAN 10. This user is VLAN 10 and this user is in VLAN, let's say, 20. IP address of PC1 is 10.1.1.1. IP address of PC2 is 20.1.1.1. Fine. So here, to make communication between VLAN 10 and 20, you have to create SVI on multi-layer switch. So here you will run one IP address on interface VLAN 10. Let's say IP address is 10.1.1.100/24. Right. On switch number 2, I have one SVI VLAN 20, interface VLAN 20. And on this interface, my IP address is, let's say, 20.1.1.100. So in this scenario, let's say in this scenario, how 10.1 can communicate with 20.1? I need to connect one link over here, and you will configure this link as trunk. Now can PC1 ping to PC2? No, because in the routing table of switch 1 we will have only 10 network. In the routing table of switch 2 we will have only 20 network. Yes or no? So to make communication here, what we need to do, either I can configure a static route between switch 1 and switch 2, or I can configure dynamic route, or I can configure dynamic protocol. So to run a static route or dynamic route, you have to configure IP address on this interface, right? Let's say here I have configured IP 12.1.1.1 and here I have configured IP what? 12.1.1.2. Now I can configure a static route or I can configure dynamic route. Yes or no? On switch number 1, I can run command IP route 20.1.1.1. Next hop IP address for this network is 12.2. Right? In the same way, on switch number 2, I can run one route, IP route, and 10.1.1.0/24. Next hop is 12.1.1.1. Now can PC1 ping to PC2 now? Can PC1 ping to PC2? Yes, it can. It can ping. Ping will work here. But what problem we have? Let's say in a static route, if we have multiple, multiple user are in multiple VLAN on switch number 1 also and on switch number 2 also, then you need to create lots of static entry. So again, that is complicated. So what you can do, you can configure one dynamic routing protocol here, EIGRP. Let's say I have configured EIGRP here. Now what will happen? EIGRP neighborship will come up between switch 1 and switch 2, right? And through EIGRP, we can exchange 10 network and 20 network with each other. But if link between switch 1 and switch 2 will goes down, if link between switch 1 and switch 2 will goes down, EIGRP neighborship will goes down. So what I can do, I can connect one more link here, and on this link also I will configure one IP address. Let's say here IP address is 21.1.1.1 and here 21.1.1.2. So now we will have two EIGRP neighborship. If we will connect one more link, we will have 3 number of EIGRP neighborship. So after every 10 seconds, both switch will generate 3 number of hello messages, and it will receive also 3 number of hello messages. So CPU utilization of devices will increase automatically if we will have 3 number of neighborship between switch 1 and switch 2. And if we will have more than 3, let's say 5 neighborship are there, we have 5 link. So to reduce these type of problem, we come up with layer 3 ether channel. We come up with layer 3 ether channel. Layer 3 ether channel. Till now, whatever things we have discussed, that is layer 2 ether channel. Right? In layer 3 ether channel, what you can do, you have multiple link between switch 1 and switch 2. Now you can bundle these link, right? And then on your port channel, right, on your virtual port, let's say P1 and here P2, on this port channel you can configure IP address. Let's say here my IP address is 192.168.1.1. Here my IP address is 192.168.1.2. Now through this logical interface we can form EIGRP ether channel. So if one link will goes down, right, still we will not have any problem, because still we have two links between switch 1 and switch 2. Clear? Any question guys in ether channel? This is all about ether channel. We can perform lab of this scenario also, or you can perform this lab by yourself also, because it is very easy. Here,
You do it, sir.
okay.
Sir, one
Mhm.
question.
Yes, yes.
Why Cisco saying that it is not recommended to use CDP on EtherChannel port
For
channel,
security
EtherChannel port?
purpose. Actually, through CDP, your devices are saying, some information like MAC addresses of device. So on switch number 1, by default CDP is running. It is forwarding CDP message. So if any attacker will connect their device to switch, right, they will get CDP message, and they can get to know
Yes.
some basic information about your device, and through that information they can attack in your network, right? CDP is used to discover connected device. Like on switch number 1, I want to check which device is connected with me, so I can run command show CDP neighbor. So it will show me, see here, one device is connected on 0/1 interface and one device is connected on 0/0 interface. Device name is switch, right?
The same switch?
Switch number 2.
Uh,
On switch number 2 I can change host name here, host name
yes,
switch 2.
but it would be better if we can see the other switch through the port channel, EtherChannel port.
Yes, or you can run show interface status command also, na, to check connected device.
Okay.
So that's why you should disable, CDP in real time. So CDP neighbor, but still it's recommendation only, right? We are still using it. This is
Okay.
previous entry. Now you can see switch 2 is connected on 0/2 interface. So spank tree is running on port channel. Okay, let me remove port channel. Say no interface P1. or interface range E0/0 and E0/1. What I can say, no channel group 1 mode desirable. On switch number 2 also interface range E0/1 and E0/0 channel group 1 mode
Sir,
auto. Hmm.
can you do LACP?
Okay.
No, no,
No.
no, no. You can say na. No channel group.
Oh, fine. Do so. EtherChannel summary. Fine. Now we don't have any group. On switch number 1 also, so EtherChannel summary.
Gee, recording is on, right?
Right.
Okay.
Channel group number 1 mode. For LACP, mode is active. Channel group 1 mode, we can say passive. And so EtherChannel.
That group number we should use that same, right? At that both switches.
No, we can use different also. It is locally significant.
Okay.
Protocol is LACP. Now in this scenario, I'm going to remove LACP configuration. And this time, what I will do, interface E0/2, switch port access VLAN 10. I have put this computer in VLAN 10. On switch number 2, do so EtherChannel summary. Interface E0/1/0, switch port access VLAN 20. Interface range E0/0 and E0/1. Channel group, let's say number 10, and mode is, let's say, active, LACP, right? Then interface port channel 10, no switch port, and switch port here I can now configure one IP address, IP address 12.1.1.1.255.255.255.0. So IP interface brief. So we have one IP address on this port channel, right? And so EtherChannel summary. Also will run no switch port command, this command on port channel. Here I have run this command, you can see no switch port, this command. And then you will run so EtherChannel summary. So interface status. Okay, these interfaces are shut down. So interface range E0/0 and E0/1, say no shut here. So EtherChannel so interface
Do we need to give in the interface no switch port in the interfaces? Interface 0/1, 0/0, no switch port.
Wait. Group status. Group state. L3.
The ports are in layer 2. Port channel is in layer 3.
Correct. So interface status, say no set here. Why port is not showing over here?
Show interface status. These are in VLAN, right? VLAN 1, 0/1. We have,
So
this is routed port. Port channel 10 is routed, and the ports are in VLAN 1, switch port.
correct.
Show interface status. Can you
Wait. So interface status, okay. Okay, wait. Interface range is 0/0 and is 0/1. Okay. Now here we can configure IP address on port channel. First you need to run no switch port on physical interface as well, right? So ether channel summary, now you can see, right? And so ether channel, so we can say what detail. So which protocol we are using? LSCP protocol. Mode is active over here, group number is 10, and we can run this command here. Now ping is working between switch 1 and switch 2. Now what we can do here, I can create one SVI interface VLAN 10 IP address 10.1.1.1 255.255.255.0 and say no set also, and do so IP route. In the routing table we have 12 network and 10 network on switch number 1. On switch number 2 interface VLAN 20 IP address 20.1.1. 20.1.1.1 255.255.255.0, right? Now router EIGRP is number 10 and network 12.1.1.0 on switch number 1 also. Router EIGRP is number 10 and we can say network 12.1.1.0. Okay, so we have EIGRP neighborship, so IP EIGRP neighbor neighbor. Okay, Q count is 0. You can see we have only one neighborship, but how many physical links are there between switch 1 and switch 2? 2. So if one link will goes down also, right, we will have EIGRP neighborship. So in the same way, let's say we have multiple link, 5 links, 6 links, right? We can bundle those all link into L3 ether channel, and then we can form, a dynamic routing protocol neighborship also. And after that we can exchange prefixes also. On router, on switch number 1, router EIGRP 10, I can run network 10.1.1.0. And here router
Yeah,
EIGRP.
yes, sir. This was my question.
This was your question.
Yeah, this was my question. Here, when you do the IP neighbor, you see the other router via the port channel. But when you do CDP, you're not seeing the other router or switch via port channel. That's my
Now
question.
in
Why?
so CDP you will see only devices connected on physical interface. Here you will not see
Yes, and that making
logical
people
interface.
confused. You can see it's like you see two switches.
Okay.
Is it possible to change to see the other switch through the port channel?
No, no.
When we go to the interface port channel, we
This
put
is not
CDP,
possible.
we activate CDP inside.
We cannot
That
run
was my question.
CDP for
Why that
port
is not
channel.
supported in Cisco?
For port channel,
That
we
was
cannot
my
run CDP.
question.
See, I can try, by the way, here on interface, port channel 10, and say CDP run. On switch number 2, interface, port channel 10, CDP run. And now show CDP neighbor. So I have enabled CDP on port channel. Then also we are not able to see neighbor. So CDP neighbor. Are not able to see virtual link.
Okay, okay.
Is it
Now
CDP?
any CDP, by default CDP is enabled on all switches, on all Cisco switches. It is again Cisco proprietary protocol. It is used to check layer 2 information, right? Directly connected devices. Like on switch, if I want to find how many devices are connected on, or which devices are connected on which interfaces, we can use CDP protocol. But nowadays we are not using. We have actually two protocols, CDP and LLDP. CDP is Cisco proprietary, LLDP is open standard. But CDP is not secure, LDDP is also not secure. Both are unsecure protocol. So if anyone will connect their device, they will get CDP message. They can, get basic information about device. So CDP, so you can see CDP messages, hello message of CDP, sending CDP packet every 60 second, and hold on time is 80 seconds. Means after 60 seconds, it is sending one CDP message from their each interface, from their all interface. Debug CDP events. Okay, so it have received one CDP packet on 0/1 interface from switch number 2, right? So it will make one entry in their CDP table. A device whose name is switch 2 is connected on this interface.
Actually, what you said about that LLDP? What is the use of LLDP?
Same use,
To check that layer 2 connectivity,
connected device.
connected device.
Yes. So EtherChannel is over. Now we have next string protocol, that is,
So one more, so
yes, yes, go ahead.
one more question on EtherChannel. On the switch one,
Mhm.
both physical interfaces 01 and 00. Is it possible to bundle fast Ethernet and Giga Ethernet?
No, Ethernet, again, Ethernet standard is
Because
different.
they have to be the same speed. But okay,
Same speed, and even if you will configure, you can configure a speed manually as well. You can change it. Even you will change the speed. If you will configure same speed, then also EtherChannel will not come up because of Ethernet standard. Right? Ethernet standard will be different for gig link and for fast
okay,
Ethernet link. So Ethernet standard should also be same.
okay.
Sir, can you give this command? Show LACP sys ID.
So
Show LACP sys ID.
LACP
Sys ID.
system ID.
Yes.
Yes,
This is the base MAC of switch 1
correct.
and priority. Show LACP neighbor.
So LACP neighbor. Yes.
Is this the port number you told? 0x1. Some priority and port number.
This is priority. Priority. This
Priority.
is device MAC address.
Some
This is age.
this port number is there. You told 32768 dot something.
Mm-hmm.
Is that the one port number?
LACP port ID of this port will be 32768.1.
For 1/0 port, how it assigns? For 0/0, it's dot one.
Actually, in real time on switches, you will get, first interface will be 0/1. You will not get 0/0 interface. There is no any interface 0/0 on switches.
For 1/0, how it assigns?
For 1/0,
0/2 is dot 2. For 1/0,
for 1/, again you will not get 1/0 interface now on switches. 0 means what? 1/0 means what? 1 is slot number and 0 is port number. So what I am saying, port number will always start from 1 from here. 1, 2, 3, 4. If you have 24 port switch, so you will get port number 1 to 24, not from 0 to 23. Or even if you have 0, then it will add 1, I think, in that scenario. Any other command? So LACP counters. So this is first port, 0/1. This is what stack number. First number is showing stack, second number is showing slot, and third number is showing port number. So I'm talking about this port number, right? LACP port ID will be this port interface ID. At 32768.1 will be LACP port ID of this interface. Interface range. So interface status, include connected. 21 and 22. Interface range f1/0/21 to 22. Channel group number 10, mode active. So LACP neighbor. So EtherChannel summary. So LACP so LACP this port number is I think different thing. This is not what we are talking about.
In fact, these ports are in hexadecimal.
Yes, it is in hexadecimal representation.
Hmm.
'Can anyone convert it into decimal?
X won't come in hexadecimal, right?
Right.
Some other thing.
It's 23, 17,
This one,
17. This is 24, 18, I think.
but this is 21 port number. Then we have to check it in book. We have only one option. We have to again read book. And here if I have mentioned in this note, but LACP port ID is, again I am saying port ID is combination of priority plus interface ID, right? I think LACP is going to, calculate interface ID in hexadecimal, and why it's not showing exact number, but I'm damn sure LACP port ID is same, right? Priority plus interface ID, and interface ID is like interface number. Wait a minute. Let me check LACP protocol here. LACP port ID activation by lowest port priority of EtherChannel by default. This one, okay, lowest port number priority plus interface number. Active interface, those have lowest LACP port ID. Same thing is same thing. Switch election LACP system ID, okay. For 2 link it is going to use 1 bits. For 4 links it is going to use, okay, 2 links at least 1 bit side is okay. So you can see how it is performing load balancing. It will convert it into binary and then decimal. For hexadecimal value 0, binary interface is 1, for
So have you
interface 1.
shared this document to us?
Yes, yes, you have it. In group
Okay.
also you can check. Recently
Lot
I
of
have shared it
documents.
in group.
Okay.
Okay guys, I will check it. How it is calculating port number say 0x17. Okay, but in your book also you will see same theory, same theory, because I have copied these all things from Cisco official book. So in book also you will see LACP port ID is priority plus interface ID, and it is representing in hexadecimal. So maybe because of that we are not able to correlate exact port ID. Interface range f1/0/1, sorry, 1 not 21 to 22. Here what command I can run for to change priority? In global config mode you can change priority, right? And on interface you can change port priority. So here I can say LACP port priority. So LACP internal port priority is now 10. Interface range f1/0/21 to 22. LACP port priority. Only we have option of port priority here. LACP system priority. We can change only system priority over here. So we have only these two commands. For interfaces we don't have, because we cannot change interface ID na of switch. So okay, what I will do, I will also read book. I will check if I will find any answer of this. So LACP internal, that how it is using this port number, I will let you know. Leave it for now. For now, if anyone will ask you or interview will ask you what is LACP port ID and how switches is going to select 8 active ports in LACP, so you can say on the basis of LACP port ID, right? And LACP port ID is combination of two things: interface ID plus port priority. By default port priority is 32768 and lower value is best. Lower value is best. Now what next protocol we have guys in switching? Port security. In switching, we have covered basic switching, VLANs, trunking. We have covered VTP, DTP, STP, EtherChannel. Right. So now we have port security. Tomorrow we will start port security. Or first we can cover access control list, ACL. Then we will move to port security.
HSRP, VRRP, GLBP.
Yeah, yeah. We will cover those topics in last.
I don't find MST videos for in your channel. Multiple spanning tree. Do you have any?
I think so on my YouTube channel that video should be there, right? Actually, I was searching my stacking video also, right? Stacking video is still not available on my channel. Don't know why, but I had uploaded that video. For MST also, let me check once. Here is MST configuration. Okay, this is configuration of MST. I have to make some videos again, like video on stacking. I think so on MST, multiple spanning. There is no video. So only configuration of MST is available on channel, right? So I will upload some videos like videos on stacking on MST,
VTP
right?
pruning?
VTP VTP pruning is also not there.
No, I saw your entire video. I don't find it. That message is also half of it you explained in that video.
Video length is 1 hour 34 minutes.
But it doesn't have that pruning.
So what is inside this video?
That messages, everything. uh, we learned.
Except pruning.
Yes,
Okay.
it's not complete.
Message is also pending. Messages.
Messages is there, but it's not complete. One, two types I forgot, but it's not complete.
Join message.
Mm, I have to see it again.
Okay, I will check it. I will
Uh,
check it. Don't worry. I will make one video on pruning, VTP pruning. Let me know. One video on stacking, one on MST, one on pruning. Anything else? Any other
IPSL,
topic?
IPSLA.
IPSLA is there. IPSLA is there. I'm 100% sure. IPSLA. There are multiple video on IPSLA. You can see one video on ASFR wall also and on router also. IPSLA is there. Policy based routing is also there. Any other topic should I upload on YouTube? Stacking, MST, and VTP pruning. VTP messages also. Dhana.
VTP messages is there, but I don't know whether it is complete. I forgot. It's there in that A to Z VTP.
Yes, yes, A to Z. Okay, so I will upload the video on these three topics, right, in this week. In this week, I will provide you videos on stacking also, MST and pruning.
Do you have any videos for Cisco DNA?
For Cisco DNA, no. On my channel, it's not available. You can visit my another YouTube channel as well. For DNA, you can visit to this channel. I think LAN and WAN. So 8 videos are there on Cisco DNA. Then we have one playlist for Python.
For wireless, you have any videos?
Uh, for wireless, I have one video on my channel. Like you can learn basic things. What is SSID, wireless. So you have one video on my channel on wireless. This video. If you want, I am sharing the link. It will cover CCNA wireless. Policy based routing, BGP, STP, CCNP lab, software, VPN, OSPF, VRF is also there. There are 3 video in VRF. So I will recommend to all guys to watch this playlist as at least VRF. There are only 3 videos, but in these 3 videos you will get complete knowledge of VRF. Then these are not for you. Here EtherChannel.
So Cisco ICE also. Currently, nowadays, Cisco ICE is one of the most hot topic in network industry,
Yeah,
security
now
industry.
you know, now my friend will make videos on those topics also, right? We will upload on this channel, on PM networking channel, right? But now those videos are not available, but definitely in future we will provide you complete video of wireless security, right? SD-WAN. Earlier I was
Yes,
working
why
alone
not
on
do
this
the
channel, but
training,
now,
training live training also, no? Live training
yes.
on those
Y-
topics
yes,
after
we are
SD1.
providing live training. You can see here we are now launching training on these all topic on all courses. See, CCNA and CCNP, SD-WAN, CCI Enterprise, CCI Service Provider, Python and Automation. Now we are launching these all course in Jan.
January. CCI when?
CCI 10th Feb.
Then.
I will be not trainer, but okay,
Okay.
I will be no trainer in for any course.
Why, sir?
I think this is my last batch.
When are you going
Maybe
to write your CCIE?
in 2024 next year.
Mm.
in March or maybe in April.
For that reason, you're not taking, or
Yes, yes, for that reason only. But definitely I will make videos for YouTube sometime whenever I will get time. But I will not take live session. And after CCI, see what will happen. First, I want to work in Cisco for few years,
Mhm.
right? So that's why I'm going for CCI lab exam. But all trainers are good guys, highly experienced, right? People who is working in like company like Juniper, Cisco, those trainers are going to take these classes. Okay. Okay then. The trainer here, you are able to see some videos, right? This video made by Amit sir. He is going to take automation class, right? On LAN and WAN technology. This channel is of Losser. He is working in Cisco. He is going to take CCNA and CCNP batch. And if you will go for enrollment to him directly, he will charge you lakhs of rupees for CCNA and CCNP. His fee is 1,40,000, sometimes 70,000 for CCNA, like that. Very costly.
Who is taking that Python automation, sir?
Law, sir. Oh, sorry, Puneet.
How,
You can watch this video.
how much the fees going to be for that one?
20,000 for automation Python for CCNP dev net.
How long it will, the duration for the course?
Around 6 months.
Mhm.
Okay, and if you want to see his video, so what you can do, you can watch this video. Let me tell you.
So guys, now
He is going to take automation batch. This sir.
24 और यहाँ जो आईपी दिया मैंने 192
So this video is in
168
Hindi,
डिवाइस मैंने स्टार्ट नहीं किया ना
but you can find some video in English also. Okay. And
you will be expert in this level. Again, you need
he's
to spend so much time on the NSC area. And NSC area create a suboptimal routing, right? If you guys remember that, we have seen the concept is called as a forwarding address, right? So NSA area create a problem with the suboptimal routing.
he's going to take CCNA and CCNP batch. Okay. But guys, again, if you guys want to attend, you don't need to pay anything. You are allowed to join his batch also, right? I will allow you. I will allow you guys.
For CCNA, CCNP?
Yes, for CCNA, CCNP. You don't need to pay anything.
Prapulji,
And
Yes.
I joined in the middle of the course. Can you please allow me for next batch?
Yeah, definitely.
Yeah. Don't forget, please.
If you need, videos like recording, if he will not, let's say, if he will not allow to join live session, then definitely I will provide you videos. If anyone need, you can let me know. Definitely I will provide you recording of each class.
we need it, sir.
This
Yes,
na?
for me also, sir. Indeed.
Okay. I will share, recording of each class to you guys. So you have, already learned OSPF protocol, and again you are going to, if you will watch his video, so you will get some real time experience, like how actually we are implementing OSPF in real time. And on YouTube or even anywhere on internet, you cannot find what is the disadvantage of OSPF. Like generally, no one can teach you what is the disadvantage of OSPF. Everyone will talk about advantage only. So what is the advantage of OSPF over EIGRP? But these guys are going to teach you what is the disadvantage of OSPF also, so that you can understand next protocol like ISIS protocol, why we come up with that protocol, what was the problem with EIGRP. Like only one reason, right? Routing by rumors. All routers were dependent on their neighbor. Only this reason. Because of that we are not using EIGRP, right? And what is benefit of EIGRP, guys? Can anyone tell me what is the benefit of EIGRP over OSPF?
Unequal load balancing.
Okay, great.
Yes.
Anything else?
The configuration and design is simple.
Very good. Great. Unequal cost load balancing and easy to implement. Then
At fast convergence.
fast convergence. Okay, OSPF is also, by the way, fast. Okay.
But if you compare that OSPF,
Yes, yes. EIGRP is faster than OSPF. Oh, sorry. Oh, sorry, guys. Yes, anything else? And EIGRP need less memory, less process, less CPU than OSPF. Because OSPF maintain what database? It will have information of each link in the network. Good. Okay then. Oh, recording is